All right, so for lesson 5.2, we're covering something called factoring, common factoring, and then we're going to do factoring by grouping. But what is factoring in the first place? Well, factoring is when we take a polynomial and we break it down into a product of smaller, more simpler factors. That if we took those factors and multiplied them back through each other, we'd actually end up with the original value. So basically, we're breaking it down into its components, ideally speaking. So this is if expansion and simplifying was expanding it out. This is the opposite operation. We're trying to take it back to where we were before. You're like, well, why would we want to do that? Well, it depends on the problem. Sometimes we need to get the equation into a certain form, and that's going to help us solve some other type of problem. So this is all just building up our tool set. Okay, so with that in mind, let's hop to it. First up, so when we run a writing in factored form means that we're going to write as a product. What does that mean? A product. So that means a multiplication, right? Writing in factored form means to write as a product. So for example, if I have a 6, I can break that down into 3 times 2. Okay? That is factoring. I've broken it down into its components, that if I multiply them back together, I'll end up with the original value. So the term greatest common factor, we're going to use the short form GCF. For two more numbers is the greatest number that divides both of those numbers evenly. So this is the greatest number that divides both of those numbers evenly. So let's do an example. So imagine we have 12. What are all the factors of 12? What are all the numbers that divide 12 evenly? Well, of course, 1 does. 2 does as well. So does 3. So does 4. So does 6. And so does 12. Those are all the factors of 12. How about 18? Well, 18 has 1. It also has 2. We can also divide 18 by 3 easily enough. We can't do 4, but we can do 6. And then the next one is going to be 9 and then 18. So looking through here, what is the greatest factor that divides both of them evenly? Well, 18 doesn't. 18 is bigger than 12. 9 doesn't go into 12. So the next one is 6. So 6 is our greatest common factor. Well, this is important because this allows us to break this whole thing down. So the greatest common factor of 12 and 18 is 6. So the greatest common factor, GCF. I want you to learn that term. So the GCF for 2 or more powers is the power with the lowest exponent. So the greatest common factor for 2 or more powers. So if I have x squared and I have, let's say, x to the 5th, well, what does that mean? It means it's the power with the lowest exponent. So the greatest common factor of these two things would be x squared. Okay? So the greatest common factor for 2 or more powers is the power with the lowest exponent. So the GCF of x to the power of 5 and x to the power of 8 is x to the power of 5. It's the lowest of the two. Okay? As I said before, factoring is the opposite operation of expanding. We're trying to bring it back. We can expand to check our answer if we wanted to, so you can go back the other direction. If you end up where you started, you did a great job. So the first step in factoring any question is to find and factor out your greatest common factor. Okay? So the first step is to find and factor out the GCF. And this is always going to be the case. There are going to be certain situations where you simply don't have a GCF. So for example, if I had the number 17 and 3, there's no GCF of these things other than 1, and dividing by 1 doesn't solve any problems. So that doesn't work. Okay, so let's look at our number over here. So we have 4x minus 10x. Let's scroll down a little bit so we can see all of our problems here. So we have 4x minus 10x squared. What is the greatest common factor? What is the greatest number that divides both coefficients? 2. Okay, so I'm going to be dividing out a 2. What else? What about my exponent? What is the smallest exponent? Just x. So I'm going to factor out 2x. And what does that actually mean? It means that I'm going to divide 2x from each of the terms inside. So if I take 4x and I divide it by 2x, That just leaves me with 2 left over. You're like, what do you mean? Where did that come from? So if I have 4x and I divide by 2x, well, 4 divided by 2, that's just 2. X divided by x, what happens when we have division of powers? We subtract the exponents. So x divided by x is the same thing as saying x to the power of 1 divided by x to the power of 1. So we subtract the exponents. So we have 1 minus 1. That's x to the power of 0, which is just 1. So that's the same thing as saying 2 to the power, or 2 times 1, which is just 2. So that's why it divided the whole thing out. Okay, now we have 10x squared. We're going to divide out our 2x. 10 divided by 2, that's 5. X squared divided by x, we subtract the exponents. So 2 minus 1, that's just 1. So we still have an x here. That's the whole thing. Figure out what is your greatest common factor and divide each term by that greatest common factor. Let's go to the next one. So we have 6, 9, and 3. Greatest common factor of all 3 of those things is a 3. Okay. What is the greatest common factor for our variables here? Our powers. Just a. That's the lowest one. So we have 3a over here. So now we're going to divide each term by 3a. 6 divided by 3, that's a 2. A to the power of 3 divided by a, so 3 minus 1, that's going to be a squared. 9 divided by 3, that's just going to give me 3. A squared divided by a, well, that's subtract the exponents. We just dump with a again. And then finally we have minus 3a divided by 3a. Oh, these go completely away. So the minus still sticks around, so it's just a minus 1, right? Maybe, what do you mean by that? Well, I have minus 3a divided by 3a. That's the same thing as saying something like minus a over a. Well, we know a over a is just 1. So that's the same thing as saying minus 1, which is what we ended up with over here. So that is factoring. We factored out our greatest common factor. So let's go down to the next one. What is our greatest common factor of these 3? 8, 2, and 4. Well, the greatest common factor is a 2. All right. What about for the exponents? Well, we have m cubed, m squared, and m to the 4th. So the greatest common factor here is m squared. What about the n's? Well, n only exists in the 3rd term, so we can't factor it out because we can't take away an n from the other terms. So that doesn't get touched. So we only have 2m squared. So 8m cubed divided by 2m squared, 8 divided by 2, that's 4. M cubed divided by m squared, we subtract the exponents, so that's just going to be m. Now the next one, negative 2m squared divided by 2m squared. So the whole thing gets canceled out, but we still have the negative, so it'd just be negative 1, subtract 1. Now we have 4m to the power of 4n. 4 divided by 2, that's just going to be 2. M to the power of 4 divided by m to the power of 2, we subtract the exponents, so we just have m2. 4 subtract 2 is 2. And then we don't touch the n because there is no n that got factored out, so the n is exactly left alone. My m looks exactly like my n. Better be very careful about that. There we go. And we're done with that one. There's no terms to clean up or anything like that. If I wanted to, I could rewrite this just to keep it up proper orders. So we'd have 2m squared multiplied by negative 2m squared n plus 4m minus 1. That would be a bit of a more accurate way of writing it. Let's go to the next one. 16 x cubed y squared plus 24 x to the 5th y squared. What's our greatest common factor? Well, not 16. It looks like it's going to be 8. 8 divides both of those evenly, and it's pretty big. So, in fact, it's the biggest number we can work with. So 8, what about our x's? The smallest x power is x to the power of 3. What about our y's? That's a y squared. Okay. Now we divide each term. 16 divided by 8, that's 2. X cubed divided by x cubed, 3 minus 3 is 0, so that just goes away. They're gone. And then y squared divided by y squared, that also goes away. So we only have a 2 left over out of that. That's so sad. So now we do 24 divided by 8. Well, that's a 3. X to the 5th divided by x to the 3rd. Subtract the exponents, we end up with x squared. Y squared divided by y squared, the y squared goes away. There's our final term. 8x cubed y squared times 2 plus 3x squared. Okay, let's go to the bottom here. 21y squared minus 4x plus 3. What number divides each of these values? None. Only 1. So we can't really factor out a 1 because that doesn't do anything. Maybe there's a power that we can work with. Y squared? No, none of the other terms have y squared. None of the other terms have x other than the middle, so we can't factor out anything. So in this case, we say no greatest common factor. So no number or variable in common. No number or variable in common. So we can't do anything here. It is what it is. Okay, let's go to this next one. I'm sure you guys all saw this one and you're just itching to do it. Maybe not. So, what can we factor out? Well, I can divide 4 by negative 1/2. That's easy enough. And I can obviously divide negative 1/2 by negative 1/2. So I can actually factor that out. Okay, so negative 1/2, we're going to factor u out. How about x's? Well, the smallest order x we have is x cubed. So let's use that one. Negative 1/2 x cubed. Okay, now we got to do the work. Now obviously negative 1/2 divided by negative 1/2 becomes nothing. They cancel each other out. And then we have x to the 7 divided by x to the 3. So we just subtract the exponents. So we end up with x to the power of 4. All right, what about this next one? 4 divided by negative 1/2. 4 divided by negative 1/2. Well, we're dividing by a fraction, so that's the same thing as saying 4 multiplied by the reciprocal, negative 2 over 1. So what does that mean? That means 4 times negative 2, so that's negative 8 over 1, or just negative 8. Okay, so that's going to be minus 8. Now x cubed divided by x cubed, that just goes away. And there's our final term. So that is basic common factoring. So we're looking for that greatest common factor. That's the idea. But wait, there's more. Of course there is. So now we're going to get into something called grouping. Grouping. This is where we have to do a little bit more recognizing when we look at a term. And you have to pay close attention to detail in this one. So a common factor can be a whole bracket. What do you mean by that, Mr. Lane? I'll show you soon. So a common factor can actually be an entire bracket. So this is seen when we want to do factoring by grouping. And I'll show you with the first example. So down here we have 5 times x plus 2 plus 4y times x plus 2. We can see that both these sets of brackets are exactly the same. Let me rewrite this in a way that might be a little bit easier for you to see. Let's pretend that x plus 2 is just an a. So we have 5a plus 4y a. What can we factor out of there? Well, we can factor that a out of there. We don't have a number that we can factor out, but we can factor out the a. So the a would come out to the side, and we'd still end up with inside with 5 plus 4y. Well, in our example over here, a is really x plus 2. So that's x plus 2, 5 plus 4y. So really what we did is we actually factored out that entire thing. This is just a simpler way of looking at it because the numbers are easier. Or the letters, I guess, in this case. So we can factor out that entire set of brackets. So we're going to factor out that x plus 2. What goes inside the brackets? Well, look what happened over here. We just combined the two coefficients of those brackets. In this case, 5 plus 4y. And we're done. If you multiplied these through, you'd end up back where we started again. So do we need to do any work from here? Nope. This is our goal, just to factor. So the same idea over here. We have 4a minus b plus 3a times b minus a. Uh-oh. Those aren't the same. A minus b is not equal to b minus a. So what can we do? Well, first of all, let's rearrange that b minus a. So if I have b minus a, I can rewrite that as negative a plus b. But that's in the right order of our first term, but it's got the wrong sign. So I can actually factor out a -1 from here. So if I divide both terms by -1, I have a -1 on the outside. My negative a becomes just a. And my b becomes negative b. Oh, look. Now I have an a minus b on both sides. But that -1 comes and works with that 3a. So let me rewrite this a little bit so you can see everything. Oops. So we're going to leave the 4 and then the a minus b all alone. And over here on the right-hand side, we're going to write this whole thing out. We have plus 3a, and inside we have negative a plus b. Now we're going to factor out that -1, so that -1 gets combined with that 3a. So we end up with 4 times a minus b minus 3a, and then internally we have a minus b. Now we have terms that we can group, a minus b. So we factor out the a minus b, and then the second term is just the combined coefficient values. I guess let's call them multipliers, not coefficients. So 4 minus 3a. And there we go. That one's obviously a little bit more complicated to recognize because it's not exactly the same. So sometimes we have to manipulate things to make them. Factor by grouping, same idea. So looking at these 4 terms, can we group any 2 terms together so we can somehow get to the point where we can factor out an entire group? Well, let's try. So what I'm going to do is I'm going to take these first 2 terms and I'm going to group them together. And then the second 2 terms, I'm going to group them together. They're obviously not the same. So let's factor them individually first. So from this 12x cubed and plus 2x, what can I factor out of there? Well, I can factor out a 2, and I can factor out an x squared. Okay? So that means internally, I'll get 6x and then plus 1. We factored out that entire piece. On the right-hand side, what can I factor out? Well, I can factor out a -5. I can't factor out any variables, just the -5. So what happens when I have -30x divided by -5? I end up with just 6x. -5 divided by -5 is just 1, so plus 1. Oh, look, we have a common set of brackets now, so we can factor that out. 6x plus 1 multiplied by 2x squared minus 5. Factored by grouping. Same idea on the next one. Just keep going, rinse and repeat, rinse and repeat. So group what you can that looks like it belongs there. Sometimes you might have to rearrange the equation a little bit to make it work. In this case, not so much. So we're going to group the first 2 terms and the second 2 terms again. It's not always going to be so nice, but it is this time. What can I factor out here? I can factor out a 5m. Can't factor out a t, but I can get out a 5m squared. So 5m squared t divided by 5m squared, the whole 5m squared goes away and we just end up with a t there. Minus 10m squared. 10 divided by 5 is just 2. And the m squared gets canceled out. So we have just t minus 2. What can I factor out on the right-hand side here? No numbers, but I can factor out a t. Okay? T squared divided by t, just subtract the exponents, and we end up with just t to the power 1, which is just t. Minus 2t divided by t. The t's cancel out, so we just end up with a 2. And there we go. We got a common bracket again. So we're going to factor out the t minus 2. And then we're going to combine our 2 multipliers. So we have 5m squared plus t. Okay, so far so good. Let's go to the next one. Can we still keep doing this? We'll see. We're going to group, we're going to group, and we're going to group. What can I factor out of the first one? Only a w, because there's nothing else that's common to both terms. So just a w. And inside we'd end up with x plus y, because the w's cancel out in each term. And in the next one, what is common? Only a z this time. So we're going to factor out a z. And then inside we have x plus y. All right, we got a common set of brackets. So we have x plus y, and then w plus Z. I'm intentionally writing my Z's like that with the line. I don't normally do that, but just because my handwriting, sometimes my Z's look like 2's. I don't want to confuse you guys. All right, last one on this little piece here. So can we group anything? Yeah, of course we can. I'm going to do this without drawing the brackets in this time so you get used to this. So in the first two terms, I can factor out a 3x. And factoring out, dividing 3x squared by 3x, the 3's go away and the x gets reduced by 1. So we end up with just x here. And then the negative 9x divided by 3x, negative 9 divided by 3 is just minus 3. And the x's cancel out, so we end up with just x minus 3. Can we do anything with the last one? Well, it's not really helpful, but I can look how similar it is to this x minus 3. I could rearrange this. When I rearrange this, I'd end up with negative x plus 3. That's still not quite right because the signs are wrong, which means, just like I did up here, I could factor out a negative 1, and I'd end up with x minus 3. So that's what we're going to do. Negative 1 times x minus 3. There we go. We got our two group terms. So we have x minus 3 multiplied by 3x minus 1. All right, more factoring by grouping. So the next piece. This is kind of a word problem where we have to understand what we're actually trying to do here. It says find the possible length and width of a rectangle with the area 5x squared y minus 10x plus 3xy minus 6 units squared. Now, we know that we're trying to, it says it has an area. So it's telling us the area is equal to this whole thing. 5x squared y minus 10x plus 3xy minus 6. It's telling us this is what the area is. We also know that area is equal to length times width. That somehow this whole thing is length times width. So let's see if this helps us as we go down. So let's factor this. This is why we do factoring, so it can solve problems like this. So what can we do? Well, we can factor by grouping again. I can group the first two terms, and I can group the last two terms. So let's try this out. So from the first two terms, I can factor out a 5x. I can't do any higher than that because there's only one x to give in the second term there. So if I divide the first term by 5x, the 5 goes away. One of the x's goes away, so we end up with just xy. And then on the next one, the negative 10 divided by 5 becomes negative 2, and the x goes away. So we have xy minus 2. Okay, next one. What can I factor out here? Well, I can factor out a 3. The second term has no variable, so just the 3. So let's factor out the 3. So the 3xy just becomes xy. And negative 6 divided by 3, oh, that is 2. So minus 2, sorry, minus 2. And there we go. We have our terms again. So we complete our groupings. We have xy minus 2 multiplied by 5x plus 3. Okay, so we finished our factoring, but how does that help us? Well, what is our goal? Our goal is to find possible lengths and widths. Does this help us? It does, because we know that area is also length times width. Oh, look, length and width, and they're being multiplied. So we solved our problem. So since area is equal to length times width, that means, therefore, the possible lengths and widths are... Now, we don't know which is which, to be honest, so that's why we're saying the possible. The possible lengths and widths are x, y minus 2, and 5x plus 3. There we go. So that is factoring. Common factoring by using the greatest common factor, and factoring by grouping. Now what you're going to find is, as we move forward, we're going to combine these ideas. So even in these ones, we used common factoring by finding greatest common factor at every step while we were doing the grouping. So almost in every case that we go forward, you're going to find that the more complex problems are actually going to require a number of different strategies to solve that problem. That's it for now, and we'll see what's coming up next.